DeitelCh, Chapter 11 in Edition 10 of the textbook. We're going to talk about exception and exception handling. So let me share my desktop and look at the PowerPoints. Oops, we're not at the end. Just one second. Let me get at the beginning. There we go. Chapter 11, sorry. Exception handling. A deeper look. Now, why a deeper look? Introduced it a little bit in sections before. I kind of ignored it as I went through in the classes. I think in Chapter 7 he talks a little bit about exception handling. But now we want to look at it in real detail. Exception handling. What is an exception? An exception is an indication of a problem that occurs during the program's execution. Okay, and it is different than an error. And so exception implies that it occurs infrequently. We really hope that that's the case. You as the programmer want to program to handle this. Okay, the program can continue executing with exception handling. So you might be able to handle it, do something, and the program will go on. And that becomes very critical when you think about it. Typical ones you've never seen before, of course, is array index out of bounds exception when you try to read past the end of an array. Class cast exception, you're trying to turn an employee into an insurance object. No pointer exception, you created you declared an object but you never created it. And only classes that extend throwable. Okay, we'll see where throwable comes in the hierarchy scheme. Directly or indirectly can be used for exception handling. Here's a bunch of them that you've seen throughout the book, and you will see throughout the book. Lots more than this exist. Exceptions are thrown. That's the terminology we'll use. The exception occurs by a method detects a problem that is unable to handle. The stack trace, another terminology you should get used to. That's the information displayed when an exception occurs and not handled. You've seen that red stuff at the bottom of Eclipse or NetBeans and you curse it. Well, actually that'll give you a lot of information to help you fix it when you go on. It'll give you the name. Okay, and it will show you that it got called from this line in this method, which got called from this line in this method, etc. All that information will help you debug the program. Now, there are certain ones that you must handle, certain ones that you should handle, and certain ones that you just aren't going to handle. And so we'll talk about those as we go through. We can't divide by 0. So there is such a thing as an arithmetic exception, and it'll arrive a number of things, but when you try to divide by 0, that will be a problem when you do that. So let's say we have this little method here, very simple, okay, where we're going to return numerator divided by denominator, and we ask somebody to enter a number, enter another number, and then call that method. Well, you would hope that it works out fine. In this case, it does. 100 divided by 7, not a problem at all. Notice it does integer division. Again, keep that in mind. All the remainders get dropped if you divide an integer by an integer. If I put in 100 and 0, it throws an exception. That's the terminology you use. Throws an exception. This one throws an arithmetic exception, divided by 0. And it tells you again that stack trace of where that occurred. If you put in the word hello, it's not an arithmetic exception, it's a input mismatch exception. It was expecting an integer, and you put in a string. Now, this is called the call chain as you go through, and you can look at this and see where it actually occurred. The very last line here says it occurred in main method, okay, on line 22, okay, when you actually did that, and you can go up and look at it. That was called from quotient, or quotient. Let's start from the top. The exception was thrown in quotient, in the method quotient, okay, and that was called from main when you actually do that. So you can look at that. The top row indicates the call chain, tells you where the throw point was. That's where the actual exception occurred. Prior examples that input numeric values assume the user would put input. Okay, put real integers like they should, and if they don't, we get something like an input mismatch exception. And so we can have different types of exceptions for different things. Now, we want to be able to handle that. Okay, and notice that we are going to throw an arithmetic exception here in the quotient. It possibly could throw an arithmetic exception, and then we're going to want to handle it. Okay, now how do we handle it? Well, go back to the main method and notice that we have added another little phrase area here, try catch. Okay, we're going to try to do this stuff. We're going to try to ask the user to enter a numerator, a denominator, and then do the method call in line 29. And if that works, it's going to print it out and continue loop equals false. Now, we'll see why you have to have that loop. They've got a do loop in here as you go through. And part of it is that if line 29 throws an exception, it goes down to the catch, handles the exception, okay, but then the program ends. It does not come back and try again. So what he's got here built in very nicely is a way to keep asking the user over and over and over again until they actually put in valid values. You've got to put this extra loop in. It doesn't automatically go back. No language that I've written in automatically goes back and says, oh, yep, that wasn't good. I'm going to let you try again. I'm going to let you try again. Okay, exception handling tells you the problem. It does not allow you to go back and re-enter unless you put your own looping in like this, which is a good way to do that. Okay, and notice we've got in here two catches, because we have two different types of exceptions. If it's an input mismatch exception, we're going to say you must enter integers. If it is an arithmetic exception, we're going to say you can't divide by 0. And so notice that a try can have multiple catches. Now it works wonderfully. And notice we get the exception printed out, and the user gets to try again to do it. A nice way to do that. The try block includes code that might throw an exception and code that could not execute if the exception would occur, and consists of the word try and curly braces. Exceptions may surface through explicitly mentioned code in the try block, although deeply nested method calls initiated by code in a try block or from the Java virtual machine. Point being that the exception could get thrown right where you're at, or it could be from a method call that is deeper in this stack trace as you look through. The catch block, also called a catch clause or an exception handler, catches and handles the exception, or it should. You need at least one catch block, and we'll look at another thing, or a finally block. Okay, right after the try. You can't have anything else in between it. The exception parameter identifies the exception type, and the name enables the catch block to interact with the caught exception. We'll see that. When an exception occurs in the try block, the catch block that executes is the first one whose type matches the type of the exception that occurred. So you could have multiple catches, and the first one that is the right type. Now, what do I mean by right type? Coming off the hierarchy chain of the inheritance, and we'll see that as we go through. The system error, standard output, that's why it turns red. Okay, system.out is a buffered printing to the console. System.error is a unbuffered. System.out is black, as we know. System.error is red when you do that. You cannot put code between the try and the catch. The ending brace of try has to be right before the catch word when you do that. And you can have multi-catches. You can say catch arithmetic exception or this or that in one catch. Typically you write separate catches because you want to do different things based on which type of exception was thrown. Uncaught exceptions if you don't have a catch block, okay, for that type. You may still have catch blocks, you just don't have one for that type. And then what happens is it does blow up. Now, Java does use a multi-thread mode of program execution. Each thread is a concurrent activity. One program can have many threads. If a program has only one thread, an uncaught exception will cause the program to terminate. It just dies. If it has multiple threads, okay, which we will see later in 220 and in 246, the uncaught exception will terminate only the thread in which the exception occurred. Not applicable here, but that's good to know in the back of your mind. We'll look at those kinds of things later. If an exception occurs in the try block, it terminates immediately and transfers control to the first matching catch block. After the catch block is handled, control resumes after the last catch block again. Okay, it does not go back and retry the things that it skipped in the lines of code. If no exceptions are thrown in the try block, the catch block is skipped, and finally always runs. We're going to learn about finally here in a little bit. Finally is where you would actually clean up resources, do things of that sort, and it has code in it that you want to always run whether an exception is thrown or not. When a try block terminates, local variables declared go out of scope. Keep that in mind. Okay, the scope is the try. When the catch terminates, local variables declared also go out of scope there, so be careful on where you're declaring your variables. Once a catch block catches it, the remaining catch blocks are ignored. Okay, and finally will run if it's there. Now, what's a throw clause? It specifies the exception a method might throw if problems occur. Typically, I don't use a lot of throws because I handle them right there if possible. Okay, but again, different ways to create it, to do it if you want to. If in the original program we looked at you did not put the throws, okay, on the method, okay, it would tell you that it couldn't handle, it couldn't compile in some cases. So I tend to handle them right where they're at. The API documentation for a method will tell you exactly what possible things could be thrown. When a method throws an exception, the method terminates, goes out of, and it does not return a value. The local variable's got a scope. We already said that. They're available for garbage collection. So when should you use exception handling? Okay, when's a good point to use this? Well, you can get neurotic about it. Okay, you really hope that if you tell somebody to give you an integer, they will, but it depends on whether you're in production. It depends on how critical errors will be. Okay, if your program's doing something where it just has to keep running, then you better put in a lot of exception handling as you go through and do it. There are times when you have to do it. Okay, we'll see that when you do SQL or when you do file I/O. When we get to chapter 15, we'll see that as we go through. So you really want to think about exception handling from the inception of the design program, designing the program itself. It's kind of like comments and documentation. People tend to do it after the fact, but you really want to think about it to begin with. It's really a way to document, detect, and recover from errors. And a lot of things will generate exceptions. You have to decide which ones you want to handle, which ones you are going to hope works fine. Hope is not a good thing when you program, huh? Now, we want to actually look at the exception hierarchy, and here you go. Above throwable is actually object. So a throwable is an object. Throwable has a number of things under it, including exception and errors. The error side of this are things that are so extreme you're not going to take care of them. Those are things like I'm out of memory, okay, in the computer. Okay, or the thread died, or whatever. You can't handle those, okay? You're not going to take care of errors at all. So it's the exception side we want to look at. There are two types on the exception side. One are checked exceptions, one are unchecked exceptions. Checked exceptions are the ones that you must handle. Unchecked exceptions are the ones that you might want to consider handling. Okay, in his diagram here, the only one that you have to handle, checked exception, is I/O exceptions. There are other ones, okay, from there. The ones that are unchecked typically have the parent of runtime exception. And notice under that, we've got a nice hierarchy chain we learned about when we talked about inheritance. Okay, we have an index out of bounds exception and the parent, which is the parent of the array index out of bounds exception. Now looking at this picture here, if you catch index out of bounds exception, it will automatically catch an array index out of bounds exception. If you catch a runtime exception, it'll catch all of those in the bottom 3 rows. And so you might say to yourself, why don't I just catch exception? Okay, not a good thing to do. We'll see that as we go through his PowerPoints. But a lot of the next PowerPoints, what he's trying to do is make the point that you should specifically catch the type of error because you may want to handle it differently. Okay, notice in his previous simple program, if it was a arithmetic exception, he told you couldn't divide by 0. If it was an input mismatch exception, he said you must put in integers. It really helps the programming to do that as we go through. And so that's what he's saying in all this stuff. You must deal with checked exceptions, as I mentioned. You don't have to deal with unchecked ones, although you should. If a subclass method overrides a superclass, it's an error for the subclass to list more exceptions in the throws clause. That's something for later. Okay, yeah. So again, we've got that arithmetic exception when we talk about that. Number format exceptions, make your programs robust. How robust? Depends. Depends on what it's being used for. Okay, again, if it's in something that is real critical, you better be doing some exception checking when you do that. If a catch handler is written to catch superclass exception objects, it can also catch all the objects of the subclass. That's what I mentioned. But don't catch exception every time. You want to catch specific ones. If multiple catch blocks match a particular type, okay, the first one, okay, is what it will catch. So placing a catch block for a superclass before a catch block for a subclass, okay, gives a compilation error. It says code not reachable. Because if you catch exception, and then underneath you try to catch arithmetic exception, the answer is it's never going to get to that code because exception caught them all. That's what he's saying. Throwing or catching type exception is discouraged. Throwing. Oh yeah. Again, don't use exception. Use specific ones when you do that. All right, how about this finally block? Finally block is all you really need to know about finally block is it always runs. That's a good thing, because that's where I clean up resources, okay, so that I don't have memory leaks. And he talks a little bit about memory leaks here when you do that. So the thing to know is that Java does not entirely eliminate memory leaks, but pretty close, okay, and so yeah, that's another whole topic when you actually do that. Finally always runs. Finally always runs. Finally always runs, except there's always an exception, isn't there? If somewhere you have a system.exit, finally doesn't run. Okay, so if you actually had code in your catch block that said system.exit, then finally will not run. Great place to release your resources. You should always release them explicitly at the earliest possible moment at which it is no longer needed. Now, the try with resources we'll talk about at the end of this chapter, added in SE7, certainly helps you with this. If an exception that occurs in a try block cannot be caught by one of the tries, finally runs. If an exception occurs and catch does handle it, finally always runs. Finally runs, finally runs, finally runs. All right, and that's what he's talking about here. So here's what we've got. Okay, he's got an example here in 11.5. All right, notice public static void main try, it just throws exception. It calls throw exception, which is a method. Okay, it catches the exception and prints out exception handled in main, and then calls does not throw exception. So if you look at this, here is his throw exception. It throws the exception, and he catches the exception, and finally will run. Here's does not throw exception, so the catch will never occur. Finally always runs. All right, I've said that enough. There you go. Enough about finally. Yeah, okay, cool. You can rethrow an exception. What does that mean? You can catch an exception and then kind of look at it and say, ooh, this isn't, I can't do anything about this, throw it again. So you just rethrow it by using the throw keyword again. When a rethrow occurs, the next enclosing try block detects the exception, and that try block catch block attempts to handle it. All right, so if exception has not been caught when control enters a finally block, the finally block throws an exception that is not caught in finally block. The first exception will be lost. The exception from the finally block will be returned by the calling method. Just some subtle points as you're doing this. So avoid placing in a finally block code that can throw an exception. Okay, who's going to catch it? Finally is the last thing to run. Exception handling removes error processing code from the main line of the program. Do not place try catch finally around every statement that may throw one. This decreases readability. One big try catch, I'm not real sure about that, especially if there are different things that can be thrown. And if you can recover and then continue on, you don't want to put those continue on lines in the try, because once it's thrown, those never come back and do. Stack unwinding. Okay, again, method A calls method, here we go, method 1. Main calls method 1, method 1 calls method 2, method 2 calls method 3, method 3 throws an exception. Okay, method 3 has no code for handling that exception, so it goes back to method 2. Method 2 has no code for handling that exception, it goes back to method 1. Method 1 has no code for handling exception, okay, so it goes back to main. Main, ooh, look at that, line 12. Main can catch the exception, and so it will catch it. The program will continue on as you go. Chained exceptions. Sometimes a method responds to an exception by throwing a different exception type that is specific to the current application. If the catch block throws a new exception, the original exception's information and stack trace are lost. Point being, only one exception can be valid at a given time. Hopefully your programming isn't so bad that we got multiple exceptions as we go then. And he shows you an example of a chained exception here. I'll let you look at that. You can declare your own exception types. We're going to do that in second semester Java. First semester we're not. Okay, it's really pretty cool. And the reason to do that is so, again, you can be more specific. And you can have it actually print out a statement that is specific for what you want that statement to print out. And so you can declare your own exception types when you do that. And does the book have, I don't think the book has an example of that. I will indeed put one in the 220 class when we do that. Let's see if he's there. Nope, he's on pre and post conditions there. Now, one of the things about that is that that new exception type must extend an existing one. It has to be an exception. Okay, so public class Diane's exception extends arithmetic exception. Okay, public class Diane's exception extends exception. That works. Typical new exception contains only 4 constructors. Typically, I don't even put 4 in there. I usually just put the first 2. One that takes no arguments, it passes the default string of what it's going to say when the exception gets thrown, and one that has a customized error message as a string. And again, 220 will be looking at that. All exception classes should end with the word exception? Yeah, I guess so. All right, then he talks a little bit about pre and post conditions because he's going to talk a little bit about assertions here because he has nowhere else to put them in here. Again, this is really 220 material. Pre and post conditions aren't, but the assertions are. We'll look at that in ITP 220 when you do that. Significant amount of time debugging and maintaining code, but you really want to think about what you expect. When I write a method, what do I expect the method to do? What do I expect the method to take in? Preconditions. And what do I expect to be the method to return? Postconditions when you do that. So a good example he's got in here is like this. If you look at the character at in the string class, okay, it has one int parameter, an index for the string. Okay, the precondition, the method character at assumes the index is greater than or equal to 0 and less than or equal to the string. That's a precondition. If you pass in something else, I would expect an exception to get thrown. If the precondition is met, the postcondition states that it will return the character at the position of the string specified by the index. Otherwise, an index out of bounds exception is thrown. Now, do you write these down? Some people do. Some people use this in their documentation. It's a wonderful thing to do, and there are ways to do it. If not, at least think about it. Every time you write a method, what do I expect the method to take in? What do I expect the method to do? And what do I expect the method to return for me when I do that? Some programmers actually put them informally as part of the general method specification. Some of them put them in the APIs. Okay, but certainly at least thinking about them will guide you to implement a method and make it a lot easier. Assertions, a cool debugging tool that was added in, I don't know, DeitelCh11V10PPt, let's say, somewhere in there when you actually do that. Let's talk about assertions, and again, it's good for debugging when you do that. Very simple thing to do. You just have a statement that says assert. Assert something. Okay? Assert some expression. Okay? At some location. Now, that expression can be variables. Okay? Now, what happens is if the assertion doesn't work, it throws an assertion error if the expression's false. All right, and so it will come out and say assertion error was thrown at line such and such. The better way to use the assert statement is to use expression 1 colon expression 2. That evaluates expression 1, throws an assertion error, and it shows expression 2 as your error message when you do that. Now, you can use them programmatically to implement pre and post conditions or to verify other intermediate states to help you ensure your code is working correctly. But there's a cool little thing about assertions. Other languages had them. We didn't have them. They added them in, I don't know, a couple versions ago when you do that. And the trick is that you can turn them on and off. So you use them primarily for debugging. You explicitly enable them when you're debugging your program. When they're enabled, obviously they reduce performance because it has to go through and do that. And then what you do is when you run the code, you disable them. When you disable them, the virtual machine totally ignores those lines, and so you're back to full performance. So instead of deleting the debugging information out of there, okay, you just disable it. So it's there. If you ever need to go back and look at it again, or maybe do some more debugging, enabling your assertions again, you can try it again. How do you enable assertions? Because by default, they come in disabled. You put a -EA option attribute on the command line. We don't use in command line. There's a way to do it in Eclipse, a little bit different in NetBeans. Google it. For the 220 folks, we will be doing this, and I will show you how to do it in NetBeans itself. So here's all you do. Okay, I ask somebody to enter a number between 10 and 20, and then I assert that the number is greater than or equal to 0 and less than or equal to 10. Okay, if it is, it goes on. If it doesn't, it's going to say bad number, whatever number it is. So notice they entered a 5, it worked. They entered a 50, and notice the exception in thread main, java.lang.assertion error. It's not really an exception. It always amazes me they put exception here. It's an error. It comes out of the error side of it, not the exception side. Bad number 50 at assertion. So you turn them on and off. Kind of cool. Try with resources. Very cool. Introduced in SE7, okay, a couple of editions ago when you actually do that. We will look at this in detail in ITP 220. All right, very cool stuff. Users should not encounter assertion errors. Okay, so turn them off. That's all they're saying there. Oopsie, that's the same thing. Try with resources. There you go. All right, cool. I'm going to do a separate movie for Chapter 15. So now we know everything there is to know about exceptions. Thanks.